For this video, 500 milliliters of water starting at 6 degrees Celsius was heated for 1 minute in microwave. In this video, I will determine the amount of power that the microwave put into warming this water, the wavelength of the waves generated by the microwave, and the number of photons that flowed into the water from the microwave. The density of water is 1 gram per milliliter, meaning that 500 grams of water was heated to raise the temperature of 500 grams of water by 17.4 degrees Celsius. The microwave had to release electromagnetic energy, which is then converted into thermal energy when it is absorbed by the water, which is measured in joules. It takes about 4.18 joules to raise the temperature of 1 gram of water by 1 degree Celsius, which is the heat capacity of the water. When we multiply this 4.18 joules per gram degree Celsius by the 500 grams of water and the 17.4 degree temperature difference, we get a total of 36,400 joules of energy absorbed by the water, or 3.64 times 10 to the fourth joules. Then, when this is divided by the 60 seconds, since the power is equal to the energy over time, and watts are the unit of power, then we get 606 watts. This is only 60.6% of the given value of 1,000 watts, but this does not mean a multi-million-dollar lawsuit. Actually, it does use 1,000 watts of power, but some of that is absorbed by the cup that the water is in, some of that is absorbed by the microwave itself, and some of it is just not absorbed. The frequency of the waves, as stated by the microwave, is 2,450 megahertz, or 2.45 times 10 to the 9th hertz. So frequency is equal to the speed of light over the wavelength. When plugging in these values, you get 1.22 times 10 to the negative 1 meters for the wavelength, or 12.2 centimeters. This is somewhere between the size of an atom and the size of the universe. The last thing that I will be finding is the number of photons absorbed by the water. So, as previously determined, the amount of energy absorbed by the water was 36,400 joules, or 3.64 times 10 to the fourth joules. And this is also equal to the number of photons times the frequency times Planck's constant, which is this. This is a small number, even smaller than this channel's subscriber count, which will go up if you press this button. You can try it right now. When you plug the numbers in, you get the number of photons as 2.24 times 10 to the 28. Here is a review of the equations used in this video. So Q, the energy that it takes to heat a liquid by a certain temperature, is equal to N, the mass of the liquid, times C, the heat capacity of the liquid, times delta T. Delta represents a change, and T represents temperature, so delta T represents temperature change. Also, that power, P, is equal to work done, or Q, which is the same as energy, over T time. The frequency of the wave, which is represented by nu, is equal to the speed of light, represented by c, over wavelength, which is represented by the Greek letter lambda, and energy, which is again Q, equals the number of photons n times the Planck constant h times the frequency, which is again nu. So thank you for watching, and I hope you enjoyed this.